Okay, so shall we look at special homework number 8?
Yeah, we can.
Have you had a chance to do the WebAssign Part 1 for Section 5.1?
Not yet.
It was due on Friday, so
I know.
so you need to send in an
Request.
extension request. Sure, just send that in. All right, I'll share my screen. Let's take a look at homework number 8. Okay, can you see it? Shall I make it bigger?
I have it put up on my screen also.
Okay. So the first part are some problems where we're going to find the formula for the general term. And we did this in class. And we can think about those. And then the second part of the homework is to calculate some products and sums. As you look at those, are there any that you feel like you might need some help with?
Starting off, can we go with, I guess, number 5?
All right. So I'm going to write it down and then I'll stop sharing so that we can see it. Special homework number 8, problem number 5, and it's the sum from I equals 0 to 4 of the quantity 2I plus 1. Okay, so I'll stop sharing. Is the focus okay?
Yep, it's fine.
So where does the indexing start? What is our first value that we're going to use for I?
Give me 1 second. I'm still writing it down.
Sure. I'm sure glad that we're doing this together. Who's a good boy? Who's a good boy? You're a good boy. Come lie down. Come lie down. Lie down. You're a good boy. You had your supper. My pup is eternally hungry. Oh, yes, you had your supper. You're a good boy. Yeah, you're a good boy.
Would we start with,
Okay, let's go over the parts of a summation, shall we?
yeah, we can.
The the part sitting here, this big part, is called the term expression. It's the formula for the general term. Now, the indexing letter isn't N, it's I here. The indexing letter can be any letter. It can be K or J or N or I. Okay, it really doesn't matter what variable we use for the indexing. The quantity underneath the summation symbol or underneath the product symbol is called the lower limit. And in this case, the lower limit of the sum. It tells us where the indexing starts. And the number above the summation symbol or the product symbol, if it's a product, is called the upper limit of the sum or product. Here it's a sum. And it tells us how far we increment I, and this will be the last value for I. So do you see where I starts?
I do it first at 0.
It sure does. So here we go. The way it works is the first thing we do is we substitute the lower limit 0 into the I. So our first term is going to be 2 times 0 plus 1. Okay? And then because this is a sum, it's plus. So you kind of think of it, okay, we're going to increment plus, and now I increments by 1. So I goes up by 1. So what's the next value for I going to be?
The next value for I would be 1,
Exactly. It's that easy.
and then we would increment to 4
Increments of 1 until we get to 4.
until we get to 4.
Yeah, that's interesting that you say increments of 4. That actually would be really interesting if we had a way to do our incrementing by more than just plus 1. In programming, you can do. But the next term is 2. Now we'll put in a 1 for the I. And then the term is whatever that is plus 1. So that's the first 2 terms. What's the next term?
The next term is 2
Times what? Oh,
times
yeah.
times 2.
Yeah, 2 times 2. You were telling me what the next indexing value is. Good. So it's 2 times 2 plus the 1. Now we keep on going and we keep incrementing I by 1. So what's the next term going to be? So we started with 0, then we put in a 1 for I, then we put in a 2 for I. Now what will we put in for I?
We put in 3.
Yeah. So the next term is 2 times 3 plus 1. Plus, keep going. And what's the
Um,
next term?
plus 2 times 4 plus 1.
Nice, nice. What's the next term? It's a trick question. That is the last
Um,
term. Do you
yeah,
see
that is the
how?
last one. So it stops
Yeah,
there.
yeah, exactly. Because we got from 0 to 4 by increments of size 1. So we've got 1, 2, 3, 4, 5 terms. Let's figure out what they each are. Oh, and then we'll add them up. So what does this first term turn out to be? What is 2 times 0 plus 1?
3.
Oh, 2 times 0.
Sorry, 1.
Good,
1, 3,
good. Keep
and then
going.
4, and then 5, and then 6.
Careful. The third term isn't
Sorry,
4. It's 2
it's
times 2 plus the
5,
1. Okay, 5.
5,
Good,
and then 7,
good.
and then 9.
And then 9. Notice
And
that
aren't these prime numbers?
they're odd numbers.
Uh,
They're mostly prime, but the 9 isn't.
yeah, the 9 isn't.
But does make sense that you're looking for a pattern about these numbers because this is our general formula for an odd number. 2 times k plus 1 doesn't matter if we use a k or an I. Each one of these is an odd number. This is the sum of the first 5 odd numbers. Does that make sense?
Yeah, it makes sense.
So what do we got? 4 plus 5 is 9, plus 9 is 18, plus 7. 18 plus 7
26.
is uh
Or sorry,
8
you said 18 and
plus
7, so
7.
25.
Yep. And that's exactly what you need for your answer. Let's do a product one. Let's do one of the ones that's a product. The next one's a product. Let's do that one, number 6. Okay.
Okay.
So do you know how to read that expression for number 6?
No.
I'm going to teach you how to read it. You ready?
Yep.
Because it's a pie, it means product. So this is what we say first. The product from k equals 1 to 4 of k squared. The product from k equals 1 to 4 of k squared. Now you try it, you read it.
You said the product from K equals 1 squared.
From K equals 1 to 4 of K squared.
The product of K to 1, um, the product from K equals 1
To
squared
4. To 4.
to 4 of K squared.
Perfect. All right, let's calculate that. What's our first value for our indexing variable? Where do we start? And what is our indexing variable actually? Can you tell me what letter we're using?
We're going to use K, so our index starts at 1.
It starts at 1. So our first term is what?
The first term is 1. Sorry, 0, 0.
No, we're starting at
No?
1 here.
Okay, so it's 1.
1, and then the formula says square it.
Mm-hmm.
Okay, so the first term is 1 squared because we're putting in 1 for K. Does that make sense? And now we're not going to use a plus because we're not making a sum here. This is a product, so it's times. You with me?
Yep, I'm with you.
What's the next term in this product? It's a factor, actually.
2. 2 squared
2 squared. Very good. Times, keep going until we stop.
times 3 squared times 4 squared. And we stop there.
That's exactly right. Very good. So it's 1 times, because 1 squared is 1, right?
Mm-hmm. And then the next one is 4, and then 9, and then 16.
Great. So 4 times 9 is 36, and 36 times 16, let's see, 6 times 6 is 36. Remember the 3. 6 times 3 is 18, but plus 3 is 216, and then 1. It's 576. But of course, you're welcome to use a calculator. The only tricky one in that group of problems is number 8. I think you can do number 7 now. It's a sum. And again, it's something plus 1. Number 8 is worth looking at because it's a formula. N choose 2. It's the product from n equals 2 to 4 of n choose 2. Can you read it?
Yep. The product from n equals 2 to 4 equals n over 2.
Of
N of
n
n2.
n choose 2. We
Of
read
n
this.
choose 2.
This is n choose 2. Now, to work this problem, we have to remember the formula for n choose r. So let's just recall the formula. Here, our r is 2, but let's just recall the formula for n choose r in general. And then we can use that formula where the r is going to be 2. Does that make sense?
Yeah, it makes
N,
sense.
so n choose r is, and I'm going to erase some blue lines so it's a little bit easier to see. It is a fraction. On top is n factorial. On the bottom is r factorial times the quantity n minus r factorialized. Does that look familiar?
Yeah, from last class.
That's right. So we're going to use this formula, and our n is going to start at 2, and then it's going to be 3, and then it's going to be 4. And our r is going to be 2 throughout because the r doesn't change. All right, you ready?
Yep.
Okay. And it's a product, not a sum. And that's where a lot of students go wrong is we kind of get used to doing sums all the time. That's why I alternated products with sums in this homework to get you used to actually paying attention to the operator. It's a product, so we're going to be multiplying the factors, okay? All right, I'm going to erase one of the blue lines. Here we go. We're going to start the product from n equals 2 to 4 of n choose 2 is equal to, here we go. We're going to start with n equals 2, okay? So it's going to be 2 choose 2 times, what's the next term? The next factor. I put in the 2, I put in the 2 for the n here for the first term. 2, 2 is the n and the r is 2. Just keep incrementing your indexing
So
variable.
it'll be 3 over 2, and then 4 over 2,
Three choose 2.
and then 4 choose 2, and
Very
stop there.
good. Not factorial. In a minute, we're going to use the formula and we'll put a factorial in. In fact, there'll be 3 factorials in for each of these because the formula for n choose r for any of these is going to have a factorial on top and 2 factorials on the bottom. Are you with me?
Yep.
All right, that's why I wanted to do this one with you. This one's challenging. All right, here we go. All right, 2 choose 2. All right, we're going to use the formula where n is 2 and r is 2, okay? And it's going to be a fraction. What's going to go on top when we have the 2 for our n?
2 apostrophe,
2 factorial, good.
and 2 factorial.
Now, on the bottom, we're going to have 1, 2 different factorial expressions. What's the first one going to be? What is r factorial going to be when our r is 2?
2 factorial.
Very good. And then our second term that's going to be factorialized is n minus r quantity factorial.
So 2
So
minus, or parentheses, 2 minus 2 factorial.
very good. And we'll figure out what this is in a minute, okay? Let's move on and put in the formula for 3 choose 2 in here. And then we'll put in the formula for 4 choose 2 here. And then in the next step, we'll simplify stuff, okay? Is that okay?
Yep.
That way, there's a little method to our madness. There are a lot of ways to do it, but I kind of like to organize myself because this can get complicated. All right, now we're going to evaluate 3 choose 2. So n is 3, r is still 2. So what goes up here in the numerator?
3
Yeah,
3 factorial.
perfect. Now we're working on the downstairs part of the formula, the denominator. We have r factorial first. What will that be?
It'll be 2 factorial parentheses 3 minus 2 in parentheses factorial.
Perfect. All right, we're on a roll. Let's do the
4
third one.
4 factorial over 2 factorial parentheses 4 minus 2 factorial.
Good. Now, let's simplify each one of these a little bit.
In the first one, the factorials cross out.
That's right.
And that leaves 2 minus 2 factorial.
So when we cancel the 2 factorial up top with the 2 factorial downstairs, it leaves a 1 up top, okay? So it's 1 over, and what is 2 minus 2, by the way?
0. So 0 factorial.
Uh-huh. Now, here we don't see a 3 factorial downstairs, do we? So let's figure
No.
out what this is. What is 3 factorial? It's 3 times,
Times 2 times 1.
which is 2 factorial. Or you can write 3 times 2 times 1. You can do that if you want. But I stopped at the 2 factorial because we have a 2 factorial downstairs,
The 2 factorials cancel out.
and the 2 factorials will cancel. And what is 3 minus 2?
1.
So there'll be a 1
1
factorial down
factorial.
there. Okay, good. Again, we don't see a 4 factorial downstairs. We see a 2 factorial, and this will be another 2 factorial, won't it? So we need to expand the numerator until we see a 2 factorial. So how can we write 4 factorial?
2 times 2 factorial.
Nope. It's 4 times 3,
4 times 3 times 2 times 1 factorial.
and I'll just stop at 2 factorial because 2 times 1 is 2 factorial. Do you see why I stopped at 2 factorial?
Yeah.
Because it'll cancel with the 2 factorial down here. And what's 4 minus 2?
2 factorial.
So we have 2 copies of 2 factorial downstairs.
So they
So
cancel out.
one of them can cancel out, but there'll still be one of them down here, right?
Correct.
So do you know what 0 factorial is? Let's just recall also. 0 factorial is defined to be 1. And then n factorial, we've already been using that, is n times n minus 1 factorial. We've been using that already. And this is for n greater than or equal to 1. And we've already been using that by expanding 3 into 3 times 2 factorial. And here we expanded 4 to 4 times 3 factorial, but 3 is 3 times 2 factorial. So we sort of expanded twice to reduce the 4 factorial until we saw the 2 factorial to cancel out. Does that make sense?
It does.
All right. So what is 1 over 0 factorial?
1 factorial.
Well, actually, there's no factorial up here. And what is 0 factorial?
1. So it's just 1.
Yeah, it's 1 over 1, or you could just write 1. That'd be fine. But I'm going to write 1 over 1 to help people, that might look at it later, right? Now, what do we have left from the middle factor after those 2 factorials canceled?
3 factorial over 1, which is
Um,
just 3.
okay, careful. The factorial canceled with the 2.
Gotcha. So then it's just 1 factorial.
And what is 1 factorial?
1, 1.
Yep. 0 factorial and 1 factorial are both just 1. Good. Now the factorials canceled in the third factor because the 2 factorial cancels with the 2 factorial. But we still have a 2 factorial downstairs. We'll deal with that in a minute. What's left upstairs after this 2 factorial goes away? The factorial's gone upstairs. So what is 4 times 3?
12.
Good. Now downstairs, this 2 factorial went away because it factored with the 2 factorial and it just left a factor of 1 that we don't even need to write. But we're left with this 2 factorial. Well, what is 2 factorial?
2 times 1.
That's right, or just 2. And now we're ready to get our final answer. You can either multiply the tops together and get 36 over 2, or you can go ahead and cancel the 2 with the 12, leaving a 6 up top and a 1 down there. Any way you slice it, it's going to be 36 divided by 2, or 18. Isn't that fun? Okay, you don't have to lie to me and tell me it's fun. Can I give you a do later problem though, so that you can practice this idea on your own?
You can.
And then when we have office hours tomorrow night, you can take a picture of it and send it to me before the office hours and I can check it. Will you be able to make office hours tomorrow night at 7?
Tomorrow night I would have to see. I can email you tomorrow and let you know confirmation.
What's a better time for you to have a Monday office hour, Jessica? Because I know
Earlier in
you
the
have
day.
earlier
It's
in the
just earlier
day.
in the day. Yeah, it's just like earlier in the day is all.
Okay. Um, would it help you, for example, if we had, do you have classes on Monday?
No, but I have like different meetings for work.
Okay. So when you say earlier in the day, do you mean like 5? Or-
Preferably earlier, like noon, 1, 2, more
Okay,
so.
all right, I'm checking my calendar right now. I know I've got a couple appointments tomorrow, but I think they're spread out.
Well, tomorrow I do the meeting at 10, and I'll probably be out by 12 or 1. So if you wanted to do 2, that would be fine, 2 or 3.
Okay, I have an appointment tomorrow at 2:30, from 2:30 to 3:30. So I could do, uh,
I could do 3:30 for an hour. Or I guess it's for the due later or for an hour, either one.
you can do 3:30 tomorrow?
Yeah, I can do 3:30 tomorrow.
All right. I'll send around a notice that we'll have a 3:30 office hour tomorrow. I might make it 3:40. Is that okay? Is
Sorry, that's
three
fine. Yeah, that's
is
fine.
3:40 okay? All right.
3:40 is
So
fine.
using the same information, did you write this information? And this is in the notes as well, of course. But here's a do later. Because now that we've worked the homework problem, you need to practice it on your own. You understand? And also, if you check the class notes, we looked at 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial. Like we looked at those first. So you can check the notes for that from Tuesday, I believe. All right, so I'll call this problem 8 prime because it's similar to problem 8 that we just did, you know. Find the product from n equals 3 to 6 of n choose 2. And then I'll give you one more. Problem 8 double prime. The product from R, so I'm going to change the R now. R equals 0 to 2 of 5 choose R. So it's a little different. The R is going to change in the second one. The N is going to change in the first one. Are you good?
Yeah, I'm good.
Okay. Do you need to look, do we need to look at any of the other problems on the special homework? Or do you want to try to go ahead and look at those tonight and maybe try that WebAssign for section 5.1 part 1 and get that extension request sent over to me, okay?
Okay, will do.
All right. Is there anything else you want to do tonight? Do you want to look?
No, there was some nations, but I'm just gonna try to work through them. Like the rest of the homework problems. Or actually, can we do number 10 as the last one, or would
Let's
that be
take
too
a,
many?
I can make a different one that's
Yeah, it's a
similar.
different one. Different
Oh,
one for number 10
sure.
and 9 wouldn't be bad.
Are you worried about a negative number raised to a power?
Yeah.
All right, I'm gonna make a problem. I'm gonna call it 10 prime, and it should help you do 10 without giving away the farm.
Okay.
I'm gonna do the sum from k equals 0 to 4 instead of 1 to 5, 0 to 4 of -1 to the k times 3 plus k instead of 3 minus k. Is that okay?
Yeah, that's fine.
All right, here we go. It's a sum, so we're going to be adding terms. You ready?
Yeah, I'm ready.
All right, so this is still special homework number 8. So where does our indexing start?
The index is going to start at 0.
Okay, so that means everywhere we see a k, we're going to put a 0 for the first term in the sum. You with me?
Yeah, I'm with you.
So the first term is -1 raised to the what?
-1 raised to the first power. Sorry, raised to 0.
Right. Times, this is a times, because when they're right next to each other, it means we're multiplying, but we don't have to put the times symbol. Times 3 plus what?
Times 3 plus 0.
Good. That's our first term. Plus, all right, now we're ready for the next term. So we plus, because it's a sum, and we increment k. What's the next term going to look like?
Would it be 1? I'm sorry, would it be 0?
It's -1
Or -1 still. So -1
raised to
um
the what?
raised to the first power
Good. Times,
times 3 plus 1
nice.
plus
You're on a roll.
extra credit.
Plus the next term. What's the next term going to look like?
The next term is going to be -1 raised to the second
Uh-huh. Times.
times 3 plus 2
Nice.
parentheses plus -1 raised to the third times 3 plus 3
Good.
parentheses plus -1 raised to the fourth
Uh-huh.
times 3 plus 4 parentheses. And then that's the last term.
That's nice. Nicely done. All right, let's take this slow. We're gonna work on each term and then we'll figure out what the sum is at the end. Is that okay?
Yeah, that's fine.
All right. One of the things that you need to recall is that -1 to the k is equal to -1 when k is odd. Whenever k is odd, then -1 raised to the k is just -1. Like -1 to the 1 is -1. -1 quantity cubed is -1. -1 to the fifth is -1. Do you know why that is? Because if we have 3 -1s that we're multiplying together, that's a negative times a negative times a negative. And that winds up being negative. Do you remember that?
Slightly.
And -1 to the k is equal to +1 when k is even.
I do remember that actually.
Okay, well, let's just remember. Do you remember that if you multiply uh, -1 times -1, when we multiply two negatives, we get a positive?
Yeah.
When we multiply two negatives, they cancel each other out and we get a positive. But that means if we multiply together three -1s, Well, the first two multiplied
Cancel
together
out, so we get a
is
negative.
+1, but then we're multiplying by another negative, and that hits us back down to the -1. See what I mean? So if you
Yeah, I
have
recall
an
that.
right, so if you have an even number of negative signs, they cancel each other out and you get a positive product. But if you have an odd number of negatives, then your product will be negative. Does that help?
It does.
And one of the things to also realize is that anything raised to the zero is +1. Or just remember, zero is even, right? Zero is even because zero is 2 times zero. It's 2 times an integer, namely itself. So -1 raised to the zero, it's like raising -1 to a positive exponent, to an even exponent, because zero is even and you get +1. Okay. And of course, -1 to the 1 is what? It's just 1 is odd. So if you put an odd number in for k, even if it's a 1, 1 is odd. So you're still going to get a -1. Okay.
Understood.
Right. Now this is -1 squared. This is -1 cubed. What would -1 to the fourth be?
-1.
Is 4 even or odd?
Sorry, it'll be one, one, one.
Yeah, +1.
This is
Okay.
even.
All right. What would -1 to the fifth be?
-1.
All right. Good. So are you on board with how raising a negative to a power works?
Yeah, I am.
Good. Well, at least -1. We can look at -2 to a couple of powers in a minute just to make sure you can do problem number 9. Anyway, so now we're dealing with reducing these nice terms that you so nicely figured out by putting in 0 for k and 1 for k and 2 and 3 and then 4. And they're all pluses in between because this is a big sum. All right, so what is -1 to the 0?
-1 to the 0 is 0 is -1.
Careful.
+1, +1,
It's
+1.
+1. Yeah, the other negative. All right, so -1 to the 0 becomes +1, and it's getting multiplied times 3 plus 0. But what is 3 plus 0?
3.
All right, so that'll be our first term. Plus, we're just going to deal with the -1s first and add up, the terms in the second factor, and then we'll get the final answer. All right, what is -1 raised to the 1?
-1.
And what is 3 plus 1?
4.
Good. Now we're at -1 squared times 3 plus 2. What's -1 squared?
1.
And what's 3 plus 2?
5.
Great. What's -1 cubed?
1. Oh, cube, cube, cube. -1.
And what is the other factor?
9.
3 plus 3. It's not
Oh, sorry,
times.
6, 6. 6, and then 1, and then 7.
Great. So what do we have? We've got 3 plus a -4. That's 3 minus 4. Plus a +5. That's just +5. Plus a -6. That's -6. Plus a 7. And then we can just, figure out what that is. If you want to add the positives up together first, 3 plus 5 is 8, plus 7 is 15, minus 4 minus 6 more is -10. And so what's our final answer?
Final answer is 5.
Good. Now, in problem number 9, you actually have -2 raised to a power. So let's look at powers of -2. The signs are going to be the same kind of rule, you know, but because it's 2 instead of 1, the magnitude of the power of 2 will change. So first, let's just look at powers of 2, okay? 2 to the 0 is 1 because anything raised to the 0 is 1 except 0. 0 raised to the 0 is an indeterminate form. But don't worry, we're not going to have 0 raised to the 0 in this class, where this is not a calculus class. What's 2 to the 1?
2,
Good. What's 2 squared?
4,
What's 2 cubed?
16.
It's 4 times 2 more,
Sorry,
because
8,
good. And then 2 to the 4th. Just multiply 8 times 2.
16.
All right. So like 1, 2, 4, 8, 16. What would the next power of 2 be?
2 to the 5th.
Uh-huh. That'd be 32. Okay, great. It's good to memorize the first 10 powers of 2 if you can do it. Now, let's look at -2 and raise it to powers. The magnitudes are going to be the same as these, but the sign is going to alternate depending upon whether the exponent is even, like 0, 2, or 4, or odd, like 1, 3, or 5. So -2 to the 0, well, it's still just 1. Anything raised to the 0 is 1, okay? -2 raised to the 1. Well, that's just -2. It's the same magnitude. It's the same distance from 0 is 2, but it's going to be negative because 1 is an odd power. What do you think -2 squared is going to be? Well,
It's
first of
going to
all,
be negative, sorry, 2. 2.
all right, first of all, is it going to be positive or negative? We're raising, so
Positive.
right, it's going to be positive because it's -2
And
times
it's an even
-2.
number. So
Now,
4.
it's going to be 4. Good. What's -2 cubed? Think about what it is. It's -2 times -2
It's going to be
times
negative 8.
-2, -8. And then -2 to the 4th. See how they're alternating? Positive, negative,
And then
positive,
that's going to be
negative.
16.
Right. So I think this should be enough information for you to figure out number 9. And I think in number 9, it's not a sum anyway. It's going to be a product.
Okay, yeah, I was gonna say I can do number 9. And then just email you if anything.
Okay. All right. I think this was really productive.
Yep.
And I think
Thank you so much, Professor.
you're welcome. I will send around an announcement that we will have a 3:40 p.m. office hour tomorrow. And then a lot of people, may be able to come. But the fact of the matter is, all you had to do was ask, right? And if I can do it, I'll do it. So
All
we're
right.
going to have a 3:40 p.m. office hour, and that's Zoom on Monday, April 13th. Okay, and I'll send around an announcement. Thank you so much, Jessica, for making this office hour productive. And now we have a nice video for your colleagues to watch. You have helped a lot of people by taking the time to ask questions.
Thank you.
Have a great night.
Thank you, and I hope you have a great night as well.
Thank you so much. I'll see you tomorrow.
All right, I'll see you
Oh,
tomorrow.
if something
Hmm?
changes in your schedule,
Just email you and let you know ahead of
yeah,
time.
and in fact, I'm not going to send around the announcement until probably about noon so that I
Mm-hmm.
can let you get a handle on your day.
Okay.
It's always okay to, if you email somebody, it's always okay to change an appointment. And I appreciated your email tonight. That was really nice. All right, great. Talk to you later.
All right, talk to you later. Thank you again.
You're welcome.